Hey guys, how about some section 8.3 problems? Factor trees, your favorite. Well, let's be honest now, these are not that difficult. So what I am going to point out here is anytime you do a factor tree, one possibility is to do the factor tree clear to the bottom, circle pairs for square roots, circle three of a kind if you're going to do a cubed root problem, four for a fourth root, etc., etc. But this far into the school year, guys, we're going to shortcut this a little bit and try some big boy, big girl math. So either way you look at it, though, square root of 50 does not come out even. And if it doesn't come out even, I got to do factor tree. So there's more than one factor tree for 50. But I'm going with 25 and 2. Here's the reason. Shortcut. Now, you want to make that into a 5 and a 5 in circle pairs, you're more than welcome to do so. But I'm going to say the square root of 25. If I asked you that question, you would say 5. You wouldn't say the square root of 5. You would just say a regular old 5. So it's done. 5 and a square root of 2. All right, now shortcut for the variables. Here comes the easy part. Square roots are understood to be a 2 right there as the root number. Anything beyond that, cube root, fourth root, etc., they put them there. Like a lot of things in math, sometimes we just leave them off, and we assume that you know that. So the trick is very simply to divide the 2 into the 4. And 2 goes into 4 twice with no remainder. Done. So 5j squared raised square root of 2. Alrighty, number 2. So cube root of 40. Now there is a reason that I asked you to memorize some of these cubed root numbers that come out even. And one of those was cubed root of 8. So if I'm going to do a cubed root factor tree, then I want to try to use an 8 or a 27 or a 64 or a 125. And in this case, I can use 8. So what was the point of that? Well, the cubed root of 8 is 2. Not cubed root of 2, not any kind of root of 2, not crazy 2, regular old 2. Cubed root of 5 has no factor tree. He's done. So really, if you have those square roots and cube roots memorized, these are not that bad. So the trick for the variables, how many times is 3 going to 6? Twice. How many times is 3 going to 3? Once. And I got it. Number 3. Factor tree for 63. Well, if you realize the square root of 9 comes out even, that's a good factor tree to use. Square root of 9 is 3. Square root of 7 is done. Understood to be a 2. Divide. How many times is 2 going to 6? 3 times. How many times is 2 going to 3? Now, it doesn't go in evenly, but we can still use the same trick. So I'll ask it again. How many times is 2 going to 3? Well, it goes in there once with a remainder of 1. So that worked out pretty conveniently. I'm going to leave off any absolute values that would go into these answers. If you're in the honors class, some of these answers would need absolute values. If you're not in the honors class, we skipped doing that. So keep that in mind if you're watching this and you're an honors student. All right, moving on. So most people would say, oh, well, division, that's going to be way easier. And I'm going to tell you way tougher. I'm going to tell you it's way easier. So here's why division is easier sometimes. If I had just written that problem down without the cube roots and said 88 over 11, your brain would automatically tell you that that guy right there means division, and you would have divided it. Well, the only difference is instead of doing a regular 88 divided by a regular 11, we were doing a cubed root of 88 divided by a cubed root of 11. Same rules apply. If they divide, you're allowed to divide them. The only question would be, can you do something else? And cubed root of 8 comes out even. It's 2. Done. So that would literally be one of, if not the easiest problem on a quiz. And sadly, that's one that gets missed a lot. All right, so we'll try to apply the same principle for number 5. Fraction bar means divide. But I can't divide 1 into 81. So on this one, then we do have to treat it like separate problems. So if you were thinking about treating number 4 like separate problems, you can do it that way. It's just way harder. So really, all I have to do is ask myself, is there anything I can do with the fourth root of 1 on top? And is there anything I can do with the fourth root of 81 on the bottom? Well, the fourth root of 1, what number times itself 4 times would be 1 is 1. And if you weren't sure, you can always try a calculator on the fourth root of 81, and it does come out even. If it didn't, we would have had to have done a factor tree. But the fourth root of 81 is 3. 1/3, done. So I'm going to try the same idea here with number 6. So I'm going to start with the bottom. So again, though, fraction mark means divide. 2 divided by 49 can't do it. So I can't do what I did in number 4, but I can say, all right, I'm going to treat it like separate problems, try to do whatever I can do. Square root of 49 on the bottom, that's 7, regular old 7. Can you actually do the square root of 2? No. Can you do a factor tree for the square root of 2? No. So I'm done with that no matter what. But I can deal with the variables. Same rule. How many times is 2? Go into 2. Once. How many times is 2? Go into 3. Once, with a remainder of 1. So I've treated it like 2 separate problems, and I've simplified the bottom into 7. I simplified everything I could on the top. Done. Okay, the multiply problems, they are definitely a little more difficult. But on number 7, not so bad because you're talking about 1 square root, or 1 cubed root in this case. So I still have to do factor trees. Just don't lose track of the 3 that was out in front. Now notice, guys, I have been doing my factor trees and actually writing the root numbers down. Because if you don't, you will lose track and forget whether you're doing a square root, cube root, fourth root, or whatever. So I'm going to take the time and not be lazy and write down my factor tree of 27 times 2. Now, why did I use 27? Well, because 27 is one of the ones that you were supposed to memorize. The cube root of 27 comes out even, it's 3. I am stuck with the cube root of 2. It does not come out even. I cannot do a factor tree. But I'll go back and I'll do the z's. 3 goes into 7 how many times? Twice, with a remainder of 1. So let's just clean up the final answer. I'm not going to leave 3 times 3. I'm going to make it a 9. Variables always go next. I got a z squared. And I got a cubed root with a 2 that was stuck in there and a z that was stuck in there. Done. Okay, number 8. So, hey, not a FOIL problem. Do you see any pluses or minuses in there? So I understand why people kind of do a FOIL and go 2 times the 5 and 2 times the 30, etc., etc. But FOIL problems are only for binomials. There are no pluses and minuses in here. Well, times is times. So those guys are on the outside. If you read the box clear at the top of the notes, it did say multiply outside things together. You're allowed to do and multiply inside things together. So that is an option. I could multiply the 10 times the 30 and get the square root of 300. But that would be kind of a large number to do a factor tree with. So here's another option. I'm just going to go ahead and do a factor tree right now for these. So I got a 2 times a 5. And over here for the 30, I'm going to go 6 times 5. And I'm just going to keep going. So I got a negative 10. I got a 2. I got a 5. I'm going to write that other 5 next to this one. I don't know why I did that. Then the 6, I'm breaking into a 2 and a 3. So, shortcut whenever possible, but you can do it this way as well. I have a pair. E goes outside. I also have a pair of 2s. Goes on the outside. What was the only one that wasn't circled? The 3. Cleaned it up. Negative 10 times 5 is negative 50 times 2 is negative 100. Square root of 3. Done. So I'm going to try to squeeze this last one in really quick. Another option. Don't lose track of the 4. I can multiply everything together if I wanted to. So if I do 9 times 3, I don't get a really big number like I would have on the last one. I got an m in the first one. I get an m squared in the second one. The rule is to add the exponents. I got p4, p1, total p to the 5th. So then I can go ahead and say, well, I know what the cube root of 27 is. It's 3. 3 goes into 3 one time. 3 goes into 5 one time with the remainder of 2. Now I'm about to run out of time, guys, but imagine that becomes a 12, and then I were just to rewrite the rest of it. All right, hey, thanks for watching part 1.